We just live in a world where we have computer programs that can speak English at a human level, and we have no idea how they work, and this is terrible.
It's often surprising to people that we need to go and do interpretability at all, that we don't understand these systems that we've created.
We have no idea how you write computer programs that can do things like generate poetry, yet we have weights for a model, essentially a computer program, that can do this.
How is it that these 100 or so blocks of dumb compute are able to write essays, translate language, summarize books, solve math problems, explain complex concepts?
It's a lot like evolution. It's a lot like the way that we started with little molecules bouncing against each other, and then you got very basic proteins, and then maybe you got cells. And in the end, you have us, right? But no one designed us to make sense. Just every generation, there's this grand progression of refinement and change over time. The models are the same way.
In some important way, we don't build neural networks, we grow them, we learn them.
The whole framework behind any kind of machine learning is that rather than telling the network what to do in a very designed sense, where you're going and fine-tuning, okay, I want you to do this with this token and that with this token, you instead just provide a very general framework. And that framework is characterized by a bunch of tunable parameters, just real numbers that you can change, often hundreds of billions of them. And you show it many different examples of the inputs and outputs that you might want it to have. In this case, just random snippets of text, say pulled from the internet, and then what the actual word following was. And as long as you have some kind of procedure that will tell it how it's doing on a particular example, either saying, ooh, you did poorly on that example, you need to change your weights this way, or you did well on that example, you don't need to change too much. Then if you run this through for many, many, many different examples, presumably some kind of behavior emerges within that flexible structure.
As we train the neural network, circuits grow through it. They implement the model's behavior.
The specific behavior is an emergent phenomenon based on how those hundreds of billions of parameters are tuned during training. This makes it incredibly challenging to determine why the model makes the exact predictions that it does.
And so we're in this situation where we understand that initial scaffolding we gave it. And we understand the process that incentivizes those circuits to form. But we don't know what those circuits are, or what they do, or how they work.
Now, the reason that's important to keep in mind is that it means actually understanding what's going on is extremely challenging, because it is an entirely separate question from the design of the network itself and understanding what the computations are. But the actual question of what it's doing, in a deep way, is a very, very unsolved one still today.
Turns out that's challenging because the circuits get packed very densely. And if you want to understand them, you sort of need to pull apart those overlapped pieces. And so if we want to understand neural networks, we're then left with this challenge of going and studying this thing that we grew, rather than something that we designed from scratch.
So what is this mechanistic interpretability thing?
Interpretability is the science of understanding these AI models from the inside out. Researchers like me are trying to figure out what the networks learned and how they do what they do.
Why it does what it does. But I'm holding myself to the extremely high standard of I want to actually understand what the internal cognition of the system is. Like, what are the algorithms it's running such that it takes the inputs, produces a series of intermediate things, and then produces some legible output.